In order to evaluate logarithms, there are a few equivalent ways to find the value. So first, we'll evaluate, for our first question, log base 10 of 100. The question we can ask ourselves is, 10 to what power gives us 100? Now that is the equivalent of writing log base 10 of 100 equals x, and then writing this as an exponential form, which would be 10 to the x equals 100. Well, because 10 to the second power would be 100, that means that x, our unknown value, is equal to 2. That's one way we could do this. The second would be to take this expression, log base 10 of 100, and write this as log base 10 of 10 squared. It's worth noting that whenever the base of our logarithm and the base of our exponential value, that's the argument, are equivalent, when those bases are the same, the result is that exponent, so that this would result in a value of 2. We come to the same conclusion two different ways. So let's look at part B. Log base 5 of 1/125th. Again, we could first write the equation. 5 to what power is equal to 1/125th. Okay. And because we have a reciprocal here, that's going to be a negative exponent, so x is equal to negative, and 5 to the third power would be 125, so that would be x equals negative 3. That's one way to reason it. Or you could write log base 5 of 5 to the negative 3. Just go ahead and write that here. Log base 5 of 5 to the negative 3, because that's how we can write 1/125th with a base of 5, and that would result in negative 3. We get the same result thinking about it in two different ways. Those two things are equivalent. Let's look at a few examples. Evaluate the following logarithms without your calculator. Our first is log base 3 of 81. Well, I can write this again one of two ways. I can either say 3 to what power is equal to 81, in which case 3 to the fourth power is 81, so our result is 4. Or again, I could actually, let me just do this separately to the side here. I could write this as log base 3 of 3 to the fourth, because the base of my log and the base of my exponential argument are the same. This would be equivalent to 4. Next question I have is log of 100. Log of 100. Well, the base is not written, so let me first do that. Log base 10, it's a common log, of 100. Now I can write 100 as 10 squared. This would be log base 10 of 10 squared, and because my base of the exponential argument and the base of the logarithm are the same, my value is the exponent, or 2. So log of 100 is 2. Our next example is log base 4 of 1/16th. Okay, well, let's think about this one the other way. 4 to what power equals 1/16th? Well, I could say that's 4 to the negative 2. It's a reciprocal, so I have a negative, and 4 squared is 16. So my value here is negative 2, because in that equation, x equals negative 2. So these are my results. 4 to negative 2. And for our last one, we have log base 25 of 5. Well, let's see. We could say 5 is equal to, well, let's write this. 25 to what power equals 5. Now, because 25 is actually 5 squared, that means that the square root of 25 is equal to 5. The exponent we use for the square root would be 1/2. So this value would be, this result would be 1/2.